Okay, well, let's get started. Yeah, I would like to welcome everyone. Thank you, Bill, for jumping in for Kyle last minute. Really appreciate it. Um, what we do usually, there's a chat function in this app. So if you have questions, ask away in the chat and we'll answer it in there. And then also we will ask Bill those same questions so he can answer them per video as well. We do post this on YouTube afterwards. So if you know someone that you think would gain some value of watching this afterwards, you can share the link and Susan will send that link out to everyone. Of course, you can also just go and search for Frankensolar in YouTube and you'll find it there. It usually takes a day or two and it's going to be up. With that said, Bill, if you're ready, please go ahead.
Yes, sir. Hey, good afternoon, everyone. My name is Bill Merciel. I am with Fox ESS. And don't worry, I know it's another webinar, right? I'm not going to try to use the word revolutionary more than maybe like 6 times. But seriously, for those who have never heard of Fox ESS, we're one of the fastest growing solar inverter and battery manufacturers in the world. And we've been expanding very quickly across North America and Canada. And quite honestly, the Canadian market right now is one of the most interesting places for energy storage right now. I'm based out of Tampa, Florida, so I know that from the weather standpoint, Canada, every time I've gone to Canada, there's been like 6 feet of snow. I don't know if that's just calling it the Bill factor or not, because every time I go up there, there's a lot of snow and it's cold, right? And because let's face it, when you're in Ontario, you kind of know how this goes, right? The grid works great until there's a windstorm or an ice storm or a squirrel looks at the transformer the wrong way. That happens. And suddenly the whole neighborhood kind of just stands around a driveway asking, does anyone have power? Well, that's actually the moment when solar is pretty cool, right? But solar plus storage becomes essential. And that's what, Fox is really going to focus on. So what we do is we build high performance hybrid inverters and battery systems that are designed to make your lives, the installers, very easy, right? And that includes faster installs, scalable storage, systems that actually work when the grid decides to take a day off. So today we're going to cover that, and I'm going to share my screen in just a little bit. And we're going to cover how our Fox inverter and battery platforms work, how they fit into the Canadian Ontario market, what makes our systems really installer friendly, and that how storage is quickly becoming probably one of the fastest growing opportunities for solar companies in Ontario and Canada. Because reality is, homeowners are just starting to realize something installers have known for a while, right? The grid is great, but having your own power is even better. So before I kind of do that, I'm going to jump in and we're going to share the screen so we can kind of get started with the webinar itself. So I did try this before, and if it doesn't work now, I'm going to blame it on Maria. All right, so hopefully we can see my screen. Can you guys verify that you can see my screen? Perfect.
Yes.
All right, so welcome to the Fox ESS Canadian Installer Training. So one of the things that I want to talk about very most, and something that is probably one of the most important parts of who we are, is where we come from, what we do, and how we came into the Canadian market. So I'm going to make this pretty quick, and then we'll dive into more of the training agenda and what that looks like for today. So give you an idea, an overview, Fox ESS has been around since 2019, and believe it or not, we won the EUPD Top Brand PV Inverter Seal by EUPD Research pretty much every year since we were initiated, right? So 22, 23, 24, also going to be for 25. Now, we did hit Bloomberg Tier 1 in last quarter of 2024. This is very important. What this tells everyone that is in the fundable market for financing or any of that, tells the banks that we are fundable. This is a very, very big milestone and something that we are very, very proud of. In Germany, UK, and by the way, just so you guys know, we are a global company. We are based all the way around the world. We hail from China, right? So our headquarters are in Wenzhou, China, and we have offices all the way from Shanghai all the way through to Wenzhou. And so we collaborate with TSO, DSO in Germany. In UK, we are ranked #1. We've got literally over 350,000 systems that we have installed in Germany alone. And to give you an idea, just so you look over here on the screen, this is our Fox factory, which was in 2019. It's a 1.2 million square foot factory. We have over 2,400 employees. It is the largest inverter independent factory in Asia. We're pretty proud of that. And the fact is, we already have a new factory right next to it, pretty much adjacent, for about the same size. So to kind of give you an idea of who we are, we're one of the largest independent inverter companies in Asia. And our parent company, Tsingshan Group, is also one of the largest stainless steel manufacturers in the world. We produce almost 25% of the global supply of stainless steel. So why do I bring all this up? I just want to let you guys know we're kind of a big deal. That's all. Across the globe, part of what we do is we're going to be around for a long time. So we're not a startup company, and we're not a company that, shies away from really taking a deep dive into what works for our homeowners and our clients. Think of us like Toyota, right? So we want to make sure we may not be the coolest car out there, but we're the safest and we're going to be the most profitable for you, right? So the last thing you want is to install a product and then 5 years from now have all these issues with clients or any problems in the future, right? So with us, we're going to have less than a 0.01% RMA, which is something that is very, very important as you are talking to your clients about the product itself. So a little bit about the training that we're going to talk about. So I'm not going to read off every little thing on here, but I'm just going to tell you, by the time that you're done, you're going to have a lot more firmer grasp on how the systems work, what we do, because some of you may or may not be real integrated with battery systems currently. Might just be starting into the solar, or maybe you've never done solar or batteries, maybe an electrician or a builder. So this is an easy way for you to kind of get that intro. And by the way, we're all here to help. So if something is confusing or something doesn't make sense, please just by all means reach out. We're here to help. All of us are on the team across us and Frankensolar. So without further ado, let's talk about the system. And by the way, guys, like I said, there is a chat option in here. So if you have any questions, please put your question in the chat. We'll have some moderators. If not, at the end of this, I'll go through those questions and we'll discuss that. So let's talk about our inverter systems. The AIO Inverter Flex Series is going to be the first thing. There's 2 actual systems that we operate in Canada. We call it the Power Q, which is the all-in-one system. So if you see AIO or Power Q, those are the same things. And then we have a split system, okay? That means that we have split the inverter from the battery stack. So I'm going to show you examples of each of those, but I really wanted to focus on the 11 kW, 11.4 kW, and the 9.6 kW setup that we've got, which is the top selling brands that are right now in Canada. One thing that I will tell you is that each one of these systems integrates the charge controller, monitoring, and also the power flow, right? Nice thing about our AIO battery, it's a LiPo4. So if you guys understand the chemistry of these systems, we call it LiPo4, but it's basically an LFP. So if you hear the term LFP, lithium iron phosphate, that's what that is. We do have built-in connections with thermal stability. And what makes our product a little unique, guys, is it's a modular system. So you can go as small as 8 kilowatt hours all the way up to 28 kilowatt hours per stack, right? And we're going to talk about that a little bit more. But what about Canada is well known across the world that it can get cold, right? So one of the things that I'm super excited to bring is that we all now have heating elements in our product. So this is something that we launched last year. And our battery systems can go down to negative 13 degrees Fahrenheit for those in the US and negative 25 degrees Celsius for all of you guys in Canada. Yes, the conversion, I believe, is correct. I am kind of working on that as well. But negative 25 degrees Celsius, and that's going to be huge when you're doing your product for indoor and outdoor rated for these systems. So NEMA 4X protection on these. What I will say on the heating side of this is that if you can put these batteries in either a garage or around an enclosure, I would highly suggest that, because batteries traditionally, just so you guys know, do not perform as well on colder temperatures as they do on warmer temperatures, right? Because as these batteries go down in temperature, they slow down, right? So we do have the heating elements that will allow this to go to negative 25, but there are some areas in Canada that can get colder than that, right? So in those instances, having an enclosure will absolutely help make sure that we set the right expectation for the homeowner. Okay. One thing I do want to talk about is our hubs, right? So our hubs, you can look down here. It's a 200 amp service capacity hub. So it is service rated. We are working on the Canadian market because we do have to have a door that you have access to the breaker. But you can do up to 4 inverters per hub. So we can do AC or DC coupled. We can put a generator, a home generator, up to 200 amp. We can roll right through our hub. And then you would also do up to 3 smart loads for this product, guys. So let's talk about the Power Q. Okay, that's going to be the first one and the most popular on there. The reason why this is most popular, because if you look right here on the very top, this is going to be a inverter which sits right on top. And you'll see like the inverter, and you'll see like a little portion right here. That's going to be your BMS. All right, so your inverter and BMS is 1 unit, and then each of these modules is going to be 4 kilowatt hours each. Okay, so when you're looking at these modules, you'll see those. And this particular system, you'll see is 5 modules. So this is a 20 kilowatt hour battery system. What I love about these all-in-ones is that from a size perspective and just from a footprint, it's only 15 inches by 22.4 inches. I'm sorry, it's imperial. I'm not quite sure what that is in millimeters. I'll figure that out. I'll do that for the next slide. But it is 15 by 22, and it is almost 50 inches tall. Okay, so basically that's a little over 5 feet. And then from that perspective, our max input voltage on these, if you guys understand batteries, or if you guys used any like Solar Edge, SolarX, so some, what they call low voltage systems, these high voltage systems, we do about 600 volts on these battery systems. What that means is that the amperage obviously is way less, right? So our average operating amperage is between 50 and 60 amps. And that means that you have to use less thick wiring, right? So your wiring for this is a lot easier. It doesn't draw as much heat. So some of those, what they call low voltage battery systems, can generate a lot of heat. So you have to have moving fans. You have to have moving things inside the inverter to keep it cool. Because it's a high voltage system, those capacitors run very cool. We do not have any moving parts inside the system. And what that allows us to do is, we're going to be able to maintain a warranty of 12 and a half years, right? And so these last a long time. And I think that's going to be the really most important thing as installers are coming in here. So when we're looking at your MPPT range, so we go from 257 to 500 volts per string. So there are 4 strings and 3 MPPTs. Okay, so the first string is a parallel. That's why you'll see a 2. So it's a parallel string, and that's why you'll see the max input current at 28 amps versus 14 and 14. So there's 2 strings here. We do have the SunSpec certified transmitter installed on each of these systems. Okay. All right. Pretty simple, right?
Thanks for putting. I'm going to interrupt. Thanks for putting the transmitter right into the box. That's a big time save. That's a good thing. Thank you.
Yeah, absolutely. That's something that we've been working on for a while, but that is one of the things that we started off pretty significant with. The second system I was talking about is our split system. And so a lot of people ask, well, why do you want to do a split system versus an all-in-one? Well, there's a couple of reasons. Number one is maybe that you want to do just solar only, right? So you can do a DC inverter setup with this for solar only, and then we can add batteries at a later date. Or maybe it's a size or room. Maybe we need to split them up, right? So you can do that. So we can have a couple of functions, for that. But mostly this is going to be for PV only. And if you want to add batteries later, we have that option. That's why we have these split systems. Very similar, in fact, almost identical, because what we've done is we've taken our inverter from the split system and we kind of put it on its side and did a plug and play setup for an all-in-one system. So it's literally the same inverter. We just kind of flipped it on its side and did it for the all-in-one. What's nice about the all-in-one, just so you guys know, it is wall mount or floor mount. So you don't have to be attached to the wall, which is, really nice when you're trying to deal with load bearing and having to do schematics and engineering and all of that. So you can have it and then just basically have an elbow to attach it to the wall. So that's going to be really important because, again, we want to be able to install this in the most amount of places possible. And there's some options where maybe you can do a garage, but maybe that side of the garage is not a load bearing, wall. And so to be able to have this where you can just put it on the ground is super helpful, right? So very important for that as we kind of go through it. So the hub itself, guys. So this is the one thing that, a lot of people ask is, hey, how does this work? Can we put a breaker, a 200 amp breaker in here? So you can, and this is kind of what you see as you're looking at this. When you go from right to left, the way that this typically works, if you look on the very far right, there's a standby generator terminal, which is right here. Basically, if you have a 200 amp whole home generator, if you've got a Generac, if you've got, any type, we do dry scent, or we can do dry contact or volt sense on our 2-wire stop for the whole home generators. It is important to know we go ahead and use this as a full transfer switch. This is a full 280 bus rated transfer switch. Okay. So when the generator, if you attach a whole home generator, we can use that power, the excess power, to charge your not only your battery, but also your home, right? So when the generator comes on, it's going to prioritize your home load, and then any excess, you can use that to charge the batteries. And what's nice about this is that the way that the program works is once it hits a certain state of charge, and you can manipulate that state of charge. So let's say 90%. So when your battery gets to 90% state of charge, it will turn that generator off. Okay, so then it will use that battery power until, let's say that you set your minimum state of charge to 20. So from 90 to 20, it's going to use the battery. Once it hits 20, it's going to turn that generator back on. It's going to power the loads from the home, and any excess will be used. Some people ask, what if I have, a portable generator? So you can do a portable generator plug depending on the type. And if you do that, there's a manual option. So if you don't have the 2-wire start stop, we can just, verify, hey, as soon as power goes into that relay, it's going to flip the grid relay to the off position, and that will prioritize the power going to that home load. So the generator, depending on the type of generator, we got to be a little careful on that because, if you have a generator that you're trying to run the whole home load and it's not a whole home generator, we need to break that out a little bit because you might overload that generator and that generator will just stall out. So you just got to kind of, do the math to make sure that the generator can handle the loads that are, being ran by that hub. But we can always help, on figuring that out. Okay. So that's something that's pretty big. So as we go down, you see the grounding bar, the bonding jumper, if we're going to use that as a main service entrance, or the breaker. So we can actually put the grid either directly into the system without the 200 amp disconnect breaker right there, or you can run it with the breaker like an Eaton 200. So either way, this runs as a path through. So think of it like the half on the right side is your AC, the half on the left side is DC. So kind of think of it like that. So the grid is going to come in from the bottom. It's going to go into your main grid terminal, which is what you see right here. Once you go to the grid terminal, the power kind of goes through the system, through the smart circuits, existing terminal, etc. So if that power was to be lost, that breaker right here would go into the off position. And when that grid relay flips to the off position, we are now in islanding mode. So what's going to happen is your DC takes over on this whole side. So your solar input, either from existing solar, from AC connections, or from the Fox system, will go right onto that left side and it'll run like an island. So that's kind of how the islanding function works, which is why these batteries are really important as you would, whatever reason, to lose power either from solar or from from the grid. So that's going to be very important. The other thing is that you do have smart circuits. So I know a lot of people have smart vehicles, or like Teslas, they have electric vehicles. We can use those if you have those extra ports, right? We can actually use those to manage those in the app. So if you do have a power outage, we can turn those either off or on, depending on what you're trying to do. So there are options that we can either do with hub or non-hub systems. So some people ask, well, do I have to have the hub? Okay. I will tell you that no, there are situations where you don't need a hub, but here's what I will tell you. If you're doing a whole home backup, you're going to absolutely have to have the hub. Okay. If you're doing a partial, right? Or maybe you're just doing a DC only, right? You won't need to have the hub for that, but those are very limited situations. Even in those situations, I would still recommend using the hub, because if you ever want to upgrade the system to a whole home backup, or if you ever want to add batteries, that hub you're going to need to be able to do that. So you might as well, wire it in. Plus, the hub has a lot more functionality, right? So if you want to add a whole home generator, right, for instance. But in the case where you don't have it, the difference is when you do the capacity with a hub, you can do up to 112 kilowatt hours. With a non-hub version, you can only go up to 28 kilowatt hours. You can only do one stack. You can't do multiple stacks without the hub. Okay. So can you do a whole home backup with a non-hub system? It does show a yes here, but here's what I will tell you. The hardware size of that inverter, right? If you're going to do a full pass-through, a lot of times you're going to use a 2-aught wire, on that size. It's the terminals. We don't have the terminal size that has capacity. So unless it's going to be an off-grid system, off-grid's not a problem. But if you're doing a grid-tied system, that 150 to 200 amp service has a certain gauge wire, and unfortunately the terminals on the inverter doesn't have the right size ports for that gauge. So that's why we have to have. Go ahead.
Bill, also the manual bypass is a huge aspect, because you don't want to be the guy on your street that doesn't have power because of his battery system in his home, right?
100%.
It's a really big part.
Absolutely. So when we talk about what is a hybrid system, a lot of people think that hybrid means AC and DC. That's actually not the case. Hybrid means that you can do both on-grid and off-grid. Okay. So when we're talking about a hybrid system, right? So, AC, DC, that comes through the hub, right? Hybrid sees, hey, we can do on-grid, we can do off-grid, we can do AC, we can do, DC. You have all the practical uses that you can think of. We have that option, right? And especially in Canada, when there are locations that will, allow you to do on-grid, off-grid, or maybe their grid doesn't have the viable bandwidth to be able to take solar, right? So maybe they won't even allow an interconnection agreement. These systems are perfect for that type of situation. So something that we always want to talk about. So one thing that we talk about with local codes is that the reason we put this in there is because in the United States, there's an NFPA rule that says we can only have up to 20 kilowatt hours per stack inside, right? So depending on certain circumstances, if there's a firewall or anything like that, we can go up to 28. Some locations are more strict than others. One thing I did find out working with Canada very quickly is how lovely your inspectors are with, making sure everything is correct, right? So your inspections are, quite thorough. And, I will tell you the inspectors are, learning, but, they have a pretty good, good saying on that. So just find out on the code what location you're at. what works and what doesn't work. But we can go up to 28 kilowatt hours in a lot of areas. So I wanted to bring this slide up because for us, it's very important because we get calls a lot from clients who say, hey, I'm missing something, right? And to come to find out, it was actually in a different box than what they were used to. What I will tell you is that most of the products that we have, including the resistors, and we're going to talk about, resistors and some of the extra parts in a little bit, is going to hum right into the G2 package, all right? So in your G2 hub, that is where most of the e-stop, your CTs, the labels, the pry bar for the relays. By the way, this is another big one that I see a lot of people, they see an orange handle, right? And they don't know what it is and they just throw it out, okay? Well, if anybody's ever installed a Generac ATS, it's very similar. It's an orange handle that when you open up your hub, there is a little relay, the grid relay and the generator relay, that in the emergency case of no power and the hub did not flip that, that grid relay back to the on position. Because understand, guys, the hub is powered on the DC side. So it is powered through your batteries and through your solar, okay? So if there's a complete shutdown for any reason whatsoever, rather it be a fault, or let's just say, the battery drained and, there was a loose connection and the hub didn't flip, that customer is going to be without power for whatever reason. They're going to call you and say, hey, I don't have power, but my neighbor has power. And so you're going to ask them, hey, just open that latch, that door on your hub, and check that little grid relay. It's labeled, it's right in the middle of that hub. Is it in the on position or the off position? And if they say, oh, it's in the off position, hey, we just need to flip that to the on position. This is a way for them to be able to just flip it with that handle right from the outside. They don't have to open anything up, right? Because I will tell you that in the past, all of those relays were behind a panel. And so when you took that panel off, it's pretty intimidating for a homeowner that is not in the electrical field, right? They're looking at all this and they think that, it's going to blow up and, kill them if they touch anything. So please, 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 don't throw away anything that you see until you're sure the job is done. By all means, for verification, if you have any questions, contact Franklin or us at Fox, and we will be more than happy to make sure, everything is going. But all your stuff should be in your G2, and it's typically within the door. You open that door and all the extra pieces and parts are in there. Now, if you get a flex system, a system that does not have a hub, then you're going to get in your inverter box, right? You're going to get all of these right here. You're going to get your installation guide, the cable sticker. So this is what's going to come on the inverter, okay? So it's going to be your lugs, it's going to be your base, it's going to be your screws. And by the way, the base that comes with this power cube, you have to set the batteries on the base because that base has a closed circuit. So when you set that battery module onto that base, it's basically saying, all right, we have a closed circuit, everything will be able to charge and discharge. Because if you don't, and by the way, that's because it's NEMA 4X, it needs to protect from water ingress, okay? If you try to turn the battery on and you don't have that base on, nothing's going to happen. And then you're going to call us or Franklin, and you're going to say, hey, my system isn't turning on, what's going on? And they're going to say, well, what'd you do? And they're like, well, we installed everything looks great, right? But if your system doesn't turn on, first thing you check is, hey, make sure there's a closed circuit, that there's a base, right? Something that's pretty important. Also, you're going to have everything that's part of your top inverter. You're going to have, your doors, right? All of the things that you need attached, you should have in those systems. I have not seen any issues with things that are missing. I have only seen issues where people lose things, okay? And the problem with this is that there are some things that when you lose, it's never convenient, right? So if you lose a resistor, there is no longer a Radio Shack. Wait, you guys still have Radio Shack in Canada? Okay, I'm just making sure. I saw an A&W in Canada and I was like, oh, we haven't seen those in a while. But listen, there's not a Radio Shack, so a resistor, 120 ohm, 1 amp resistors, you cannot just go to the hardware store and pick up, right? That's the one thing that you're going to need to finish the communication. And what I will recommend to any installers that are starting to install our products, if you go to Amazon.com and you pull up 120 ohm, 1 amp resistors, I'm telling you, you can order them like 500 for like $3, right? It's a good idea just to have a few of those resistors on hand in case any of your team loses them, or you can't find them for whatever reason, because it's pretty important. Other than that, pretty much everything else, you're going to know what it is, and it's not. It's the resistors and that handle that seem to get lost. I don't know, 2 out of 3 times. So just keep an eye out for those things. So one thing that we just launched and we just got certified is our wall mount for the PowerQ. This is, going to be able to support up to 28 kilowatt hours of storage, so the full weight load on this. So this is something that we've been asking for a little bit because, especially here in Florida, where we are in hurricane areas, what we've been using up to this point was just those AC brackets that you can get, on Amazon for, large air conditioners. We've been using those, but now we have our own product and it's certified and guaranteed to hold the weight, once it's installed correctly. So we do have those in stock. And so if you need those, you'll absolutely be able to do it. And what's nice is that these attach directly to the base. So if you look, right over here on the, as far as the dimensions go, it's going to connect very, very nicely. So it's going to be a very easy, way for you to be secure, be safe, and not lose on these opportunities. So something I wanted to point out, we do have our install guidelines for those bays. One thing that I will tell you is that it is recommended that, we are certified to be 8 inches or basically 200 millimeters apart from each other, from the stacks. What I will do, so if you look over here on number 2, right over here. So if you see these stacks, you'll see like this A, that's just basically stating 200 millimeters apart or 7.8 inches. What I will tell you as my installer friends, do not just put them 8 inches apart if you ever want to work on these things. All right. If you've ever tried working on something that's only 8 inches apart, the doors are on the interior on that right-hand side. So basically, you're going to have to find somebody that is very, very skinny to squeeze in there to try to work on those if you're doing that. So if you have the room, all right, I would recommend 12 inches at least to be apart, because that will give you the room to be able to put your screwdrivers and everything inside there if you need it. If not, it's going to be tight. It's possible, it works. That's why we said, 200 millimeters apart, only if space only has that much room, guys. So one thing to cover is exactly what I just covered, right? So when we're talking about the size and the difference between these Power 1, PowerQs, and Hall. So if you're looking from a height perspective, from the top of your inverter, because again, this is a modular system, so you can go as little as 8 kilowatt hours, which is 2 modules, all the way up to 7 modules. So obviously on that 7th module, it's, you're going to be at 50 inches high. But if you take a look here, if you're going to put the hub right above the inverter, you're going to need at least 300 millimeters, or basically a foot in between, okay? If you have it any less than that, there's a Wi-Fi dongle that comes with the hub that you're going to need for communication. And so that Wi-Fi dongle does stick out on the bottom. Now you can move that dongle to the left or to the right of the hub. However, from an ease standpoint, if you've got the room, try to be 12 inches from the bottom of that to the top of your inverter. As we said before, 200 millimeters, apart, and that's what we're set up for. So according to our 9540A, we are tested at the 200 millimeters distance apart. Okay. So one thing we did when we first launched the all-in-ones, there was, a little bit of opportunity. We have since fixed a lot of our water intrusion, because what was happening before was when the installer would install these, these connectors, there wasn't a drain plug. And the original series was flush. So as you can see on these all-in-ones, you kind of see how there's a little bit of an angle right there. On our 1.0 versions, they were flush. And so what was happening was water was coming down the condensation and down those lines, or basically they weren't sealed. The conduit wasn't sealed very tightly. And so water would come in and it would go right into the box. And so what was happening is that obviously when you got your MPPTs, you've got all your electronics in here, water was coming in and was really just creating havoc on the systems. And we were shortening out, obviously, the our boards. All our stuff in there was getting shorted. So what we've done to help, one is to be aware, number one, try not to install these underneath a water spout. So if you're doing it underneath the gutter, please make sure that the gutter is not pouring onto the battery. I've had two situations where they installed it where the gutter didn't go all the way down, so it just had the hole, and it was literally right above the battery. So not, these are, again, these are NEMA 4X rated. So from external, they are rated to have water, on them. Again, it's not the best idea, right, to be put in there. So if you can help it, try to refrain from just putting things underneath water spouts. The other thing is that when we are doing the connectors, always have one if you can. If you replace those two-way connectors with either a T-type T with a bottom drainage, or if you don't have a bottom drainage, drill a hole in it. Just do a really small hole right in there so that water will drain out of that section. The last thing we need is for any of that water to go into it. Because again, that's not a good experience for your homeowners. That's a truck roll for you. So if we can just make sure that we do, watertight connectors, make sure that there's, drainage holes on those T connectors. Also, from the angle standpoint, you can see we still have that. Just kind of do what you can to make sure we minimize any water intrusion opportunities. The other thing that's a good idea for those who have done really well is we call it what they almost like a loop, so electrical loop. So water will travel path of least resistance. So if the water does come in, if you have almost like a drain loop right here, the water will settle on the bottom and it will drip without getting into your boards. So you do all of these things, guys, and you're not going to have any issue with water. So I would just recommend from a training standpoint, when you're training your team in the field, just automatically train them, do the loop, make sure that you're using seal tight connectors and you're having, a way for that water to get out in case it does accumulate. So the systems themselves, what does that wiring look like? Is it easy? Is it hard? We have done everything we can to make this as easy as possible. So from an engineering standpoint, we have 3-line wiring diagrams on our website. So if you go right up to the, us.foxess.com website, I'll make sure we'll put that in the chat for you guys to have. You can download, if you go down to the download section and you go into the 3-line wiring diagrams, we have all the opportunities that you would have. All of your diagrams are there. So if you have to send this to engineering, we can help, make sure that the engineering plans are correct. If you send your plans to an engineering firm that's never used Fox, they're going to make a lot of assumptions on how these systems based on what they know. So if you guys have never used Fox before, they're just going to assume it's, very similar to what you've already used, which means that you send them, the plans, what you're doing, they'll try to create a line set. And then when they come back, you're like, oh, it doesn't work that way. And then you have to redo it again. So this way, it's super easy. Just use our 3-line wiring diagram. Say, hey, this is the way the system is designed to work. So if you can match it to what we need it to do, right? So when they get out in the field, they understand. What's nice about these is that it actually shows exactly how the communications work, right? So, and by the way, just so you guys know, on their door Now, on every single door of the G2 hub, we do have the communication wiring layout. Okay, so if for some reason your team's in the field and they don't have the 3-line wiring diagram, and all they got is the planogram that they got from engineering that does not cover the communication, and they happen to not bring the book, well, in that case, it is on the door. Okay. And we also have the way the CTs are supposed to go inside the hub as well. Okay, so whether you put a 200 amp, this breaker right in here, or if you do it directly, it will show you exactly how those CTs go, what direction the arrow is, what L1, L2, and we even color coded the L1, L2 wiring on the CTs to make sure that you know which one was which, so that when you put it in the wiring into the hub, you know exactly where it goes. So that's something that we try to make this as easy as possible for you guys, and we kind of work at. So quick breakdown on how this works. So if you go here to the far left in the middle of the page, you're going to see utility. So we're going to map this out very, very quickly. That utility goes to your main meter in the house, right? So if we're doing a whole home backup, in this case a DC coupled system, we're going to run your utility meter right into the hub, okay? And so you'll see here that L1 and L2, that red and black, that's where your CTs, those are the grid CTs, okay? System comes through, you come look over to the left, you have your power Q inverter right over here, okay? So if you've got solar on the house and you're going directly into your inverter, this is where the solar PV wires will go. They'll go from your PV panels right into your MPPTs on the top of that inverter. Your grid is you're gonna see that right over here into the 60 amp breaker right into your hub right over here. And then this is what you call your out. So by the way, you always want to make sure that when you're looking at your hub, is the left side of the hub that is running to your panel, not the right. Okay, so I've seen some people kind of get a little confused on this. I just try to make it easy. Forget about what it's called or labeled. This is going to be coming from your left side. This is what's going to power your main load. Anything that's on your right are basically your non-essential backups. Okay, so left side to your main panel over here. Okay, all this over here on the left, in the middle of the page up, those are just communication. Like that's just going to show you how the communication lines work. Okay, so make it very simple. It looks, kind of confusing, but it's not. The color is going to match. So blue, like in this case, blue, red, brown, and light blue, it's going to match when you put it into the inverter. So the COM out, so when you look at your hub over here, this COM out on the hub goes to the COM in on the inverter. All right, you color code it. So one thing that we do have on our system is every wire is labeled on the board itself. So you're going to see like little numbers on the board. So if you're not quite sure, if you're looking at it, because some people get confused if, since that board is on its side, is it coming from the left to right or right to left or up to down, down to up, right? So as long as those match, so read it like this. So if you're looking at your COM out on your hub, obviously it's left to right. And then when you look at your inverter, it's from down to up. So that's kind of like left to right, right? So you just kind of flip it up and down. So if it's going to be blue, red, brown, and light blue, right? It's going to be blue, red, brown, light blue on the COM in on the hub. I say that because that's one thing that I've seen a lot of people in a hurry, and they get that a little bit mixed up. Okay, so if the communication isn't working right, or you see something that's weird, always check your communication lines, and you want to make sure that your hub power is there. So I've seen a lot of times on new installers, they'll go out and then don't run that hub power because maybe they forgot it or didn't see it. But this right here is a 12 volt that goes from your inverter, which is powered by your solar and your battery, to power your hub. All right. So if your power on your hub, so if your main board, so if you're looking at the very top of the hub, you'll see that little board. There should be lights on. When you turn this thing on, there should be lights that come on that board. If it doesn't, check your hub power. Okay, you got to make sure you've got that connected. Something that's pretty important. If you look on the left side over here, you'll see like the same kind of wiring diagram. This is a lot less detailed. This shows multiple systems, right? And just kind of a format of how that looks. So AC and DC. I don't think that Canada is big on microinverters, but I know that there are some out there. So if you are doing a microinverter system, well, that's called an AC system. Okay, so there's two different types. There's AC and DC. DC just means string inverter systems. Okay, that just means that you're running right from the PV right into the inverter, and you're not transferring from DC to AC back to DC. So what happens on a DC system is sun hits the PV, right? That power is DC. So that direct current goes right to the inverter, and either that inverter, our system, transfers that DC right into the battery because it's a DC battery, right? Or it converts it into AC that your home can use. Okay. On a, like, let's say we do an in-phase AC battery system. Okay. The way those systems work is that it converts it from DC to AC right behind the panel, runs it to your, to your battery, right? Has to flip it back to DC before it hits your battery. Okay. And then when it comes back out, it has to go from DC back to AC. So you're losing some efficiency when that happens. That's why you'll hear a lot of times when you're doing batteries for these homes that a string system is more efficient and better for battery systems versus, a standalone solar system, right? So make sure, and that's the reason why, is because we're not converting it, back and forth between DC and AC, because obviously AC is what's, being powered in the home, right? So if we're doing an AC system, there is what they call a solar or an AC breaker. So if you are used to installing, let's say, an in-phase where there's a gateway, and that gateway, once the combiner goes into that gateway, all your micros and all that goes into that gateway, it goes to a breaker into your main panel. So instead of that breaker going into the main panel, it would actually go into the hub. And the reason why that is super important is because we need to be able to control, that solar system. So if that solar system, I'll give you a perfect example. Let's say that the power goes out. Your battery is at 100%, okay? And your load is very small. Your solar is still producing a lot of energy. Where does that excess energy go? So if you leave that in-phase breaker in the main panel without switching it over to the hub, we don't have the ability to shut down that solar system. So what ends up happening is that when the power goes out, your solar system will also go out. Okay, it's not going to be island, right? Because the only way that your solar system would work when there's a power outage is if there's power to those inverters. All right, and the only way that would happen is through our hub, right? So if our hub has our battery systems and part of there, we island and we can put power to those in-phase AC breakers, right? And so you'll have power in that system. I know it's a little technical for those who are familiar with AC and DC systems. It's not too hard, but if you're not, please ask questions later. We can kind of work through that, right, on what that means. But
hey Bill, actually quite a fair bit of Heumaus and AP systems, microinverter systems in Canada. But would this also be a really good solution for projects that people may have built a few years ago when they may have had questions about batteries, or their customers may have had questions back a few years ago about batteries? It didn't make sense, but you could AC couple a system, right? String inverter or microinverters.
Yeah, so what's really nice about this product is not only can we do an AC connection or retrofit for anything that's pre-existing, but you can also add DC side too, right? So let's say they want to add more panels. You don't have to either stick with a full AC system, or you don't have to add to that existing AC system. You can just add a DC, the panels on top, run those right into there with the AC connection, you can run all those in conjunction. So you can do both, which is really a neat feature for our product.
Thank you.
All right, so I wanted to kind of show a little bit about what it looks on the inside of these systems. So what's a real life scenario look like? What do these look like? So very similar to the diagram I showed you before. If you look on the very far left, this is kind of where the entryway of the systems go. And so you can see here the grid. This particular one does have, you know, our 200 amp disconnect right into the grid relay. Our systems would go right into here. The CTs, which you can kind of see through the wiring right up here. So you'll see like a blue wire and a white wire on the top right over here. The grid CTs would typically go right here. If you look at the red and then you look at the black. And if you look at the hub right behind that black and red, you'll see the L1, L2 sticker right here. Those are your CT stickers, right? This is what I was saying is depending on if you have a breaker or if it's direct. If you look here on the left, there is a breaker. And so if you notice, L2 and L1 are reversed. So when you know, guys, when you put a breaker in there, it does reverse. That was L1, L2. And so you want to make sure you're cognizant of that when you're doing the CTs. That's why we have that sticker right there, just to make sure it's kind of a reminder, hey, just if you're doing a breaker, this is where the CTs should be. If you're not doing a breaker, this is where they should be. So we're trying to make this as easy as possible, you know, for everyone. And when I was talking to you earlier about the wiring, if you look here on the middle picture, and sometimes my mouse will work correctly. Yeah. So if you look right there, you'll see the yellow, and then right below that, you'll see the green wire. So if you look, L1 is going to be your yellow, L2 is going to be your green. So if you see those colors, that's what they are. Okay. We try to make sure that it's easy to make sure you can't really mess this up, you know, or if you can, you can at least figure it out very quickly. So if someone calls our, you know, Frankensolar, or if they call our hotline, they're going to ask for photos, because this is how we identify if there's any errors, and we can identify very quickly if there's maybe a wiring issue within that install. 90% of all of our communication that we have with systems that are, you know, from a customer service standpoint is at time of install, right? Very rarely do we have after calls with systems that have already been installed that's been working for a month or two. The only time that we get those calls is usually, you know, if it has something to do with software related, right? Or something happens, you know, externally, like a squirrel comes up and knocks over the battery system, right? So not that that's ever happened, but it could. If you would notice, I like squirrels. One thing you'll see down here on the very bottom left, and why we highlight that, those are the resistors, okay? The resistors do not look like this in the box, okay? So the resistors that come with the system look like black wires, all right? They come in there, and I'll show you what that looks like in a little bit, but the resistors do look like, these are the resistors that you would find on Amazon. These blue ones, white ones. These are also the ones you can kind of used to get at Radio Shack. But those are really going to be important to have extras in case you misplace those other ones. But if you look, and the reason why these resistors are there, guys, is it cuts the chain for the communication wire, right? It completes the circuit. So we can do up to 4 stacks of inverters. So what happens is when you have a hub and you take a look, and you're going to see the COM out. I know it's a little hard to see, but I'm going to do the middle picture right here. When you're looking at the COM out, and then you come over here, this is the COM in. Now, if you've got a second inverter, all right, if you've got a second inverter, what's going to happen is you're going to do the COM out on that inverter, and it's going to go to the COM in on the second inverter, and so on and so forth down the chain until it gets to that, you know, last inverter. So if your last inverter is 1, or if your last inverter is number 4, the resistors have to go into that last inverter to basically say, hey, this is the last one. All right. Communication stops here, and this is where it creates the circuit and everything communicates and it knows, hey, everything should be working properly. All right, that's why it's super important. One thing I also want to point out here, if you can look, this is labeled 1, 2, and 3, the very left picture for the MPPTs right up here. If you notice, there is nothing in the second, the second string on that MPPT1. The reason being is that this is a 3 MPPT system, all right, or 3 string. So the first string, which has 2, or the first MPPT, which has 2 strings, those need to be parallel. They have to be the same size. If they're not the same size, then you don't put anything in that second spot. You move that second string to MPPT2 and that third string into MPPT3. All right. I know that's a lot. If there's any confusion on that, reach out to us and we'll kind of work through that. Okay. So remember I was telling you about, the up to 4 stacks per hub, right? So one thing that I will tell you is that if you look here, this is considered the very far left, that's considered the 4th power queue. That's where the resistors are ending, okay? You notice why I'm saying resistors a lot, right? It's because 80% of our calls that we have on brand new installers is because they didn't put the resistors in. So all they got to do is just put the resistors in and their system works great. So whenever you're in the field or you're working with your team, just double check, make sure that the wire is correct, make sure that the wiring, colors are the same, and make sure your resistors are good. You do that, and that's going to cover, 50 or 60% of the phone calls into customer service. All right. One thing I wanted to share here, do you see this combiner box right here in the middle? So the way that we had this designed originally was that you had to have a combiner box to put in all of the 60 amp breakers from all 4 of these inverters. Well, we just launched the ability for us to be able to put all of our inverters in the hub directly. Okay. This is a very, very important thing that Frankensolar really, really demanded from us, because the cost of that combiner box was pretty significant when you're talking about install time and cost of the combiner itself, right? And I think in some cases it was between $600 and $1,500 extra per install to have that combiner box on multiple inverters. So by adding the ability to put these inside the hub itself, so there is an AC solar location where you would normally put your AC connections, and you got those 3 smart circuits, right, that we have on the top of your hub right here. So we can put, if you're not using those smart circuits and you're not using the AC connection, you can put the other hub or the other inverter breakers into there. And then in the app, there's a parallel parameter right on the hub that if you go into the app, you can change that from like smart load to Fox inverter. So you just switch it there. That way the system will know that one of our inverters is inside one of those smart circuits or the extra AC combiner. We just launched that, I think, maybe 3 weeks ago. So we're super excited about the opportunity to save all our installers even more money than what they did before. So one thing I wanted to mention is that when you are doing either a hub version or if you're doing a system without the hub. So if you are doing a system that you are not using the hub for, you do need what they call a no hub kit. All right. Why? Well, because remember, all of the stuff, like all of the resistors, data logger, and the CTs were in the hub, right? So because you're not using a hub, you're going to go to our Flex system. We need to have that no hub kit, which includes those items that you would normally get into a hub. Obviously, we're not going to put all of those kits and all of that into each inverter, because you could have up to 4 inverters per hub, and it would just be an excess amount of material that, you know, from a manufacturer standpoint, guys, we're trying to lower the cost, not increase the cost. So we put that into the hub. And then for anybody that's not using it, we have those kits. So those kits are in stock. So if you have a system where you're not using the hub, we can take care of that. We just make sure that you do have that, that kit. So give you an idea, guys. I'm not going to go too much detail on this. On our website, we do have the option for you to go in there and take a look at the 3-line wiring diagrams, not only on your DC side or your AC, but also if you're doing hub or no hub versions. Okay. So if you're doing a no hub install, we absolutely do have those wiring diagrams for you to take a look at. So if you need to just send it to your engineering plans or just review it with your install teams, you have them available for you. Again, this is kind of what a system that is not having a hub looks like, right? So if you're doing a grid connection directly, you can follow this process. Like I said, for the most part, guys, you're not going to need to worry about the no hub versions. Mostly it's primarily going to be hub. But if you do, this is kind of where, you know, again, all these are going to be on our website for you to see. But I did want to show you a little bit about what that looks like. We can put, you know, obviously the resistors and all the communications are going to be a little bit different. The CTs, you'll see in the next couple, but the CT software, we have that built in. So on our Flex systems, we can't put the CTs directly into the inverter.
If I can quickly jump into,
Yep.
Our belief is that every system should have a hub. It doesn't cost very much, actually. It's probably one of the most inexpensive hubs that I've seen out there. You know, there may be very rare occasions where, you know, you can get away without a hub, but, you know, I definitely, you know, I think Alex from our team would back me on this, that systems should have hubs. It makes the system more reliable and gives you a lot more capabilities.
Yeah, and one thing is depending on the market, right? Yeah, if you're able to do it, and once it becomes service rated, it's going to prevent having to do a lot of, you know, full panel upgrades. So the cost of one of those hubs is less than a combiner box. Honestly, I mean, it's the pricing on that is very reasonable. So good point. All right. So when you're in the field, okay, so you get this installed, you have it all wired up, you know, it looks great. What do we do then? And a lot of times we'll get calls and we're like, all right, we're here. What's next, right? Well, we got to turn it on. Okay, so pretty simple. You want to make sure all your cables are connected properly. You turn on your PV switch on the box and your AC breakers, obviously in the main panel, right? You turn all that on, and then the first thing that you want to turn on, if you look on your in your system, the battery switch is going to be to your right. Your solar is going to be on your left. That's what they call the PV switch. So that PV switch is going to manage the power going from your solar into the inverter. So it's going to shut it off at the inverter. So your power, just so you guys know, the wires themselves going to your, to your solar system are going to be hot. Okay. And that PV switch is only going to turn the power off at the inverter. All right. So I just want to make sure everyone's aware of that. So don't think your PV lines are dead, when you turn that switch off. It's really just for the inverter. So just want to make sure you guys are they know that. All right. So you turn on the battery switch first. And then what you do is you press and hold the battery power function for about 3 seconds, and then you release it. All right. When you do that, you're going to see 2 blinking, flashing green lights. That's okay. That's the warm-up procedure. That's going to take about 5 to 7 minutes, depending on if there's any error codes or anything like that. First time, it usually takes about, I would say, 8 minutes to kind of cycle to make sure it goes through all those checks, make sure there's no issues on that system. There's a lot of redundancies to make sure everything is going through, checking for, grounding issues, anything like that. If you see a red light, don't panic. Could be a couple of reasons, right? Sometimes, there's different versions of software for the product. So maybe the G2 hub just came off the line, and maybe the inverter came off the line 2 months ago. And so that version of software may be incompatible. So it's an easy fix on our part. The system should still turn on. You should still see the green lights. If it's a critical error, obviously the system, doesn't work, then there are steps for us to figure out what that is. But if it is, we got to fix the system, and it's typically going to be your wiring, or it may need a software update, right? In case you need to turn off the system, right? You want to turn the PV switch, you want to press and hold that battery power for 5 seconds. I think it's more like 10. Basically, you hold it down until your lights go off, right? Once the lights go off, you release it, and your battery is dead, right? It says wait for 5 minutes before you open the side cover of the Fox Power Q in case of repair. Yeah, we'll just leave it at that, but nobody's waiting 5 minutes for that. As long as it's off, half the time it's going to be open already when you're installing. So it's going to be very similar between the split system and your Power Q system, guys. So want to make sure, just like anything else, that all the cables are connected properly. And if you've got a system, and since all your systems are going to have the heating element, you're going to kind of see, some normal modes, and you're also going to see what they call a black start mode, right? So in the case where we need to do a black start, it's pretty simple. All we have to do on both the all-in-one and the split system is that when you're turning that DC switch back to the on position, right, you're going to hold that power button in the battery for 3 seconds, and then you're going to release, and then you're going to do 3 more times within 4 seconds. So basically just off, on, off, on, off, on. So doing that 3 times, it's going to tell that system it needs to do a power cycle and turn on, make sure that you turn on through your solar. So just want to give you guys a little information on that. And if you do see a red light, again, don't panic. What we'll do at that point is, if the system has been on and you got your cell dongle or your Wi-Fi dongle and the lights are flashing on your dongle, we're going to go ahead and commission that, and the system will tell you pretty much what's creating that fault. If there's a fault with that system, it's going to say, hey, we know there's something going on. Let's take a look at that. So the next part of what we want to talk about is the monitoring side of the app and what that looks like from the commissioning side of it. So before you get to the commissioning, the first thing that we want to do is we want to go through our little bit of a checklist, right? All electrical components verified in torque. You want to correct readings from the back, the backup load side and the MPPT. So you want to just take a meter and just check your voltages, make sure they look, correct. Safety devices operational, and your e-stop, your breakers, your hub panel board light, the Wi-Fi dongle light, make sure they're powered, right? Make sure the lights are on. And that your Wi-Fi router has 2.4 gigahertz. A lot of times you don't have to mess with this too much, guys, because the system will kind of do it automatically. But there are circumstances where somebody has like a smart Wi-Fi connection and it's bouncing between 5 and 2.4. If it goes to a 5 gigahertz, sometimes it'll kick that Wi-Fi dongle off, right? And then it will reconnect. So if you are having some issue with connecting the device, you can use your hotspot on your phone to connect. We've done that a lot of times, right? Because you're just trying to get that connection and make sure that, all your systems are up to date, all that. Now, sometimes, depending on where the location of the system is compared to the router in the home, the customer may need a extender. So those are things that you kind of get at Walmart or, wherever, and you can get it, put it into an electrical outlet, and it'll extend that Wi-Fi a little bit longer, especially if you're going to do close to an outside wall or in a garage, sometimes depending on where it's located. And for those systems that are they just don't have service, we do have a cell dongle option. So it uses a prepaid service that you can use in case your Wi-Fi is not connected. So when it comes to the commissioning, it's pretty straightforward. So there are a couple of things that we want to know before it. So if you're working with Frankensolar, then what ends up happening is, Franken works as an admin, and they can then help with troubleshooting the system, all of that. You would fall underneath an installer for them. If you guys are not working with Frankensolar for, app help or anything like that, then you would register as an admin. But work with them, before you create an account. That way they can set this up correctly to make sure that everyone has access, so that, in case they, they need help or you need to help someone, you can. So when you're signing in, so the first thing that you would do is you would just need to register, right? So this is before, you can do this before you go to the customer's home, or if the installer is sitting there right now at the customer's home. I will tell you that 90% of the time, people don't really do any of this until they get there, right? It's just the way it happens. So if that does, you would come over here, and if you register as an owner, you're going to mess up, and we're going to have to refix it because owner does not have the things that you need to set this up correctly. So owner has very limited options on what they can and can't do. We have done that so that owners don't change all of the settings, like frequency settings, things that the homeowner should not be messing, because as you guys know, as installers, the first thing that homeowners do when they get a new system is they go through every little thing, and they try to do everything, right? And if they mess up some of the frequencies, it can mess up the system, meaning that it's not going to work right. Not that they're going to actually mess anything up. It's just that if they change, sine waves and frequencies, and they go from 60 hertz to 54 hertz or anything like that, the system's not going to work right. And they're going to call you and be like, hey, my system is terrible. It doesn't work right. And then we have to go back through the settings and make sure everything is good. Installer is what you need to set up as, or as an admin. So most of the time, if you guys are working with Franken and you guys, are as an admin, all you have to do is let them know that you're about to set up an account. And what they'll do is they'll send you a code. And when they send you a code, it's an invite, then that'll be part of their program, so they can see your stuff and you can see it as well. So that's where it shows here installer and admin, and the difference between that and the homeowner. And then if you go in here and says, what is the role in your company, right? So if I'm a new installer and need to join the company, meaning that, hey, I need to join with Franken, that's going to ask for the invite. Or if they've already created the company and you want to join as an administrator, they can change those functions, right? So they can do that. So once you guys decide on how you want to set up your account, depending on which one it is, either an invite code, or if you're just going to register as the installer. So if you register as the installer, basically you'll just need the admin code from Frankensolar if you're going to do that. Or if you're the admin, you're not going to need that. You're just going to, register, and then you put your username, password, email address, etc. Once that happens, all right, you're going to get to kind of your main screen, and it's going to say, hey, I want to, do an overview. There's nothing on it. You're just going to hit that little plus sign right over here. And by the way, the first thing that we need to do is we need to connect that dongle to the internet. Okay. If we don't connect that dongle to the internet, nothing's going to happen. You're going to get frustrated. So the one thing that you can always tell is if you hit that little plus sign, it's going to come up with either scan the QR code or add the serial number of that dongle manually. So when you look at your system, there should be a cell dongle or Wi-Fi dongle that's connected to your hub. On there is a QR code. You can scan that QR code, or you can manually put that in there. When you scan it, it's pretty simple. It goes right to it. You're going to hit add device. You're going to go to, network configuration. You want to configure it, and then you're going to find the customer's Wi-Fi account, enter whichever their Wi-Fi is and their password, right? Select the network, and then you're going to press complete. Once that's complete, what will happen is that red light, there's two lights that are on the front of that dongle, a red light and a green light. That red light's going to be solid on. When that red light is solid, that means it's connected to the internet. If it's flashing, it's not connected. Okay. The green light is going to flash no matter what, right? But if your red light is flashing, that means we still need to connect it. So just be aware of that if you're in the field. If you cannot find Wi-Fi, then you can use your hotspot. done that a few times. All right. So what we're going to do, once you connect the cell dongle, we're going to fill out the information, the home information. We're going to, basically do the home name, city, zip, address, and then maybe the PV capacity, and then done. So you complete that. And then what we can do now is that we can select the invite to invite the homeowner or the end user. So at this point, you can see the system. It's created the account in the 2.0 app. And then we want to invite to the homeowner end user. We hit invite. And then you're going to put the homeowner's email right here. And then they'll have a link that they can download the app. And then they'll be able to get the login information from there. So when we invite the user, again, we put the user's email in here, we hit confirm, and then it's done, right? So you go to the plant, the email's been sent, and it should look like on that third picture, that's what you should see when you're completing the commissioning. So when the system is done and everything is going, this is what it's going to look like, all right? If it doesn't, right, or there's something wrong, you need to call us. Or call Frankensolar. Like we'll, at this point, everything should be working by the time you leave. And that, if you kind of get this into the guys' heads, right? If something's not working or you're not commissioning it or something is taking longer, you need to make a phone call, guys, because if you guys are leaving, that means you're gonna have to do another roll to that site, right? So to prevent having to do multiple truck rolls, let's just, call. Everything should be working. It's usually a pretty easy fix. Right. So whatever is wrong at this point, usually either could be a wiring or a fault, or maybe, the Wi-Fi is not working right, or maybe the guy just forgot to, commission it, and connect it to the internet. It happens. Like, call us to make sure everything's working before you leave. As far as what the homeowner will see, so when everything gets connected, they open up their app, they're going to get options. So they're going to have quick settings. And they're going to have, if it's whatever the mode is. So if you look at the work mode and they click on that work mode, they're going to have these 4 options: self-power, time of use, mandatory, or backup standby. It is going to default to self-power. All right. What that means is that the way that the algorithm works is it's going to take care of their load first, their battery second, and then the grid third. All right. If they do backup standby, it's going to use not only the grid, but also the solar to charge that battery as quickly as possible in case of an emergency. Okay, so backup standby is literally that mode, means that it's going to sit there at whatever the state of charge that the homeowner sets. They're going to sit there and it's going to just be at 100% until there's a storm, until there's a power outage. All right, time of use. That is when, because I know you guys have different options to pay for utility. So if you've got the option where you're going to do peak time versus non-peak time, this is where the time of use is really going to come into play, because you can adjust, when the system charges and discharges during that day. And that's going to be very important, especially for, how you have it set up for those homeowners. So I know a lot of you guys are going to set this to where the homeowner is going to get the most value, because I think your variance between your low and your high is pretty significant, right? I think it's like almost 30 or 40 cents per kW difference between your peak time and off-peak time. So
Bill, that's in Ontario.
Yeah.
Every province is a little bit different. Ontario has a huge difference. Places like Alberta don't have any. So it really depends. I think BC doesn't have any either at the moment.
BC does. It's 10 cents a kilowatt hour.
Is it? Okay.
10 cents.
Thank you.
Yeah. So this is big. Yeah. So this is where, the battery starts to really make an impact on those customers. Also, I always say, one of the things I always say is, if there is a delta between on peak and off peak, maybe the ROI on that delta is not crazy, but it helps pay for some of those features that you're getting as well, such as backup in case of a power outage, right? So from that standpoint, it's quite nice if you can kind of use it for both things. Absolutely. The other thing too to mention here is if you see this battery warm up, we got to make sure that everything, just double check to make sure it is enabled. I've seen a lot of times where for whatever reason that could be disabled. And like right now in the middle of wintertime, you definitely want to make sure that when you're leaving that the battery features are enabled on that. If there's a case, I've seen this happen where maybe the your app or maybe the customer's app doesn't have a good connection with our server. If you ever see that this is grayed out, this battery warm up, and you know that it has the battery option, all you have to do is just click 1 or 2 times. So you just click out of that box. You can just click anywhere on there and then go back and just click that again. It will turn back on. So I've seen that a couple of times, right? And I only say that because that's just a trick that we've learned as we've done, with these, because sometimes they time out. That's why it's grayed out. Just go back out, go back in, and a lot of times it comes up. All right. So as far as the configurations are concerned, a couple of things that we want to make sure is this is going to be for the Hub G2. And if you look at your settings, right, and you go click on the time, if this is an AC coupled system, so let's say it's a retrofit, right? The one thing that we definitely want to do is we want to make sure that the system knows that there is an AC connection on that system, all right? So if it's like an AKW, let's say 0.1 mile system, right? And it's coming in there, you just want to make sure the system knows that it's at 8.8 kW. And of course, whatever your system is, because the reason why is that our systems work off your CTs, right? And so the system needs to work and understand, what's the power capacity of that that AC system, so we can control that relay that manages the power flow of that AC connection system. In the case of, hey, there's a power outage, your battery's full, and it can recognize what it needs to do from the load to unload side. Also, we can actually control if that system exports to the grid or not, right? If you want it to set it up to where it does not export to the grid at all, you want to make sure that your export limit is set to enable. And then on your percentage right here, so power limit percentage of the grid, if you want 0 export, you want to put that at 0%. All right, that's just a useful feature because some installers will use that before PTO. Some of them, in case of a system where they can't have any export, the system is designed that we can do 0 export. Man, that was it.
Awesome. Thank you so much. Let's go do a couple of these questions. We've gotten, I don't know if you were able to follow, Bill, but there's a lot of questions in the chat. So we'll re-answer some of those quickly.
Perfect.
So that people that want to re-watch it on YouTube, because they won't be able to see the chat, they will then also know this. Okay. Does the AIO have insulated housing? Can it be installed outdoors in cold climate? Does it have self-heating capabilities?
Yes. So the answer to that, I will say, is down to negative 25 degrees Celsius, right? It is rated for that. So anything less than that, I will say we need to either have an enclosure or, so a lot of times, we put something around the system, depending on what it is. Some customers have, used one of those, I don't know if you've seen those Rubbermaid tool sheds that you can get at like Home Depot. They put those tool sheds around, the battery system outside and insulate it. Those work really well, especially if it's in conjunction with the heating option, because you don't want that wind. Because if you're negative, 30 degrees, 35 degrees Celsius, a lot of times that has a lot to do with the wind, like if you're in open space. And so if it's either by a wall or, against the wind, you're going to be in a lot better shape than if you're just in an open field. So something to combine, yes. So down to negative 25 degrees, these definitely do have a heating option as well.
Alex, are you also able to talk? Are you there? Let's see if he's. Do you know, Bill? Do you know what? I think there's a storage of down to -30, right? It's just not going to work. Is that correct?
As far as, will it go down to,
What
it's about
happens
storage,
if
like
it's
storing
cold?
it. Yeah. So like if you're in a location where, hey, we can store it in much colder temperatures, but it's not going to work, right? So what
Right.
I don't know if you guys understand, what happens, because if you're moving these electrolytes in between the positive and negative on these battery cells, what happens is it's almost like a liquid, right? And so when it charges, it can rapidly heat up and harden, the internal components of that cell. So it's called plating, right? And if that battery plates, then it doesn't go away. Those plates, you can't remove those plates. And so it can ultimately end up destroying the battery cell. The actual temperature that is ideal for an LFP battery cell is roughly 40 degrees Fahrenheit, which I think is like 10 degrees Celsius, right around there. Between 10 and 12 degrees Celsius is the ideal temperature for a battery to be at 100% charge and discharge rate, right? So,
Alex, are you there? I know I've been texting him on the side here. You should be able to answer.
Can you hear me now?
There we go.
yes.
Wonderful. Yes.
Hey, Alex, can you quickly talk about the storage and what the letter states from Fox that we have?
We're currently working on that, and exactly as you described, there's testing going on right now for exposure temperature down to -30, which means that the system, if everything goes well, can be installed at colder climate temperatures, but the system will be non-operational at that point because the heating pad will not be able to overcome the heat loss in such a cold climate. As Bill stated, -25 is the lowest temperature point where the heating pads in each battery module will be able to maintain the core temperature of each cell in exactly that operation point where the system can charge and discharge. But that's coming with more documentation in the next month.
Yeah, it's one of the things that Frankensolar does with all our partners is we always try to get all that documentation, of what happens if, especially in our very cold climate that we have up here. That being said, -25 is pretty damn good in most of the country, unless you're, in some parts of the prairies or, really far up north. When will the hub be CSA certified was one of the questions.
So for that, I'm not sure, Alex, if I know that you guys have been working through that. Yeah.
I can jump in. So the hub is already CSA certified. What is not the case right now with the design of the hub, as you saw it in the presentation, is the service entrance rating for the Canadian market. As you saw, the main breaker is in the middle, more or less, of the hub, which makes it very difficult to comply with Canadian requirements of a conductor separation between line side and load side conductors, which means the current design as it is will not be compliant with Canadian service entrance rating requirements. That's why these systems typically for full home backup are installed with an additional disconnect switch that has the service entrance rating, or a lot of installers also swap out the meter base into a meter base that has a disconnect or main breaker built in, that you can have a combined meter base and disconnect or service entrance rated cabinet in one go. And that's typically cheaper and more cost effective.
And this is the same problem that, other than GrowWatt, everyone has, right?
That's correct.
Yeah, so no other what do you call them?
MID.
MID
interconnection device, correct.
Is service entrance rated for Canada according to Canadian code, with the exception of GrowWatt, which is they only are because we walked them through that process, and we're gonna do the same with Fox to make sure theirs is going to be as well. It's just gonna take a little bit. What are the max amp ratings on the smart loads?
Yeah, so you can do 80 amps per each each breaker. So you can do, well, let me rephrase. So there's 3 circuits to this. You can do a 240 volt, or 2 240s, or you can do a 240 and 2 120s for that. So depending on what your usage, again, this hub is 280 bus rated. So if we put everything in, included in there on each side, so you got your 200, amp. This can, let's say you have a generator, then you've got your solar side of it, and then your smart loads. So you can typically do up to like 80 amps on the circuits for the smart circuits.
Then Max asked about transfer switch rating. Does it have UL 1008 certification? I think Alex already answered that in the chat as well. Alex, do you want to answer it here as well?
I can quickly answer that, yeah. So it's not a transfer switch in the conventional sense, like a generator. It's a so-called microgrid interconnection device. The difference is a transfer switch switches from one source to a middle position to another source, like for a generator. An MID is connecting the grid or disconnecting the grid, pretty much a contactor that is closed or open. From a certification perspective, the UL 1008 is a ATS requirement or service code, which means that an MID cannot be certified to an ATS and vice versa. So the right certification for that would be in the US, the UL 67 as well as the UL 869A. That's for the switch equipment and the service entrance rated for the USA. In Canada, it would be the 222, 2915 as the MID, as well as then in conjunction with the entire system. In this case, the inverter and the MID, or multiple inverters and the MID for the CSA 222-1071, the conventional inverter certification, as well as the system certification to UL 1741 in the 3rd edition. So we have the certification for the Canadian market in that combination with the inverter system.
A quick thing to add, when you're talking to your inspectors, please don't call it a transfer switch. It will confuse them massively. Call it an MID, because if you call it a transfer switch, they're just going to look up that UL 1008 and you're going to open a whole can of worms, and you're going to have to explain to them the difference between the two. Then Fari asked about visiting our Frankensolar warehouse and seeing a system live and operating. Absolutely, we would love to have you come by, and Alex and Abdel have set up a nice test systems amongst some other systems as well, and we'd love to show you, what we like about the Fox or any of the other systems. But yeah, happy to do that. Please reach out to your account rep, or send an email to sales@frankensolar.ca if you don't have an account manager, and we'd love to set that up for you. What else should we ask here? Are the CTs wrap around or solid and must be installed during hub installation?
So yeah, so they're wraparound, so you can connect them. You can install them. We do want them installed during the install process, because our systems do utilize the information from those CTs to operate properly. And so some systems that are on the market only uses information. Our systems actually utilize the information that we receive from those CTs.
Awesome. Alex, you made a clarification here, an important fact about the 250 kc mil. Do you want to quickly mention it in here as well?
Yes, the Fox G2 hub is one of the hubs that is now available with a very large conductor sizing mechanical lug or fitted. For the input, if you use the main breaker, it's actually 300 MCM or 300 kc mil. On the generator, it's a 250 MCM, and on the output side towards your electrical panel, the full home backup or the non-backup electrical panel, it's a dual 250 per phase. So you have more than plenty of capacity, even for a large aluminum conductor for 200 amp service that is now 250 MCM requirement with the new code. Or if you go with copper, then you don't have any problems there either, because you can easily connect a 3-aught or a 4-aught to those terminals.
Awesome, thank you.
I did see a question there from Dave about the export limit password protected. Currently, it is, at the installer level only. Homeowners do not have the option to change that. We do not have a specific password for that that setting, but typically it's password protected from the installer side. So, we're
Yeah,
always
that's what the inspectors are looking for. They don't want the end customer to be able to change it back up to beyond what they've already certified it for. So that's just a specific question that's come up a bunch lately with the DSSs. So great, thanks for the answer. Very helpful.
If no solar is needed, does the AIO kits manage the transfer and charge from AC, or the G2 hub is needed? Let's say we have a sub panel with essential loads that was feeded on a generator, no ATS, and it's getting replaced by an AIO 11.4 20 kilowatt hours. Would it be integrating well without the hub? Alex, you answered that question.
Yeah,
would
I
be
got my
possible.
answer. Yeah. Thank you, Alex. I got my answer while the session. Yep.
Alex, you want to quickly do it for everyone?
Yes. So as Bill mentioned, there are two options, either with the hub or without the hub. And without the hub, it would be the internal transfer switch or contactor. We want to be precise here. And yes, if it's below 150 amps service or sub panel, then yes, that's possible with any other equipment. Without any other equipment.
Perfect. Are the AP system rapid shutdowns compatible with this system? All our inverters that we're bringing in are SunSpec certified. Therefore, they do work with the AP Smart Rapid Shutdown. In another question, there was about Tigos. You can use Tigo optimizers as well, but you will need a CCA kit with those if you want to use the Tigo optimizers. Then I'm just going to wrap it up here. I had one question I saw about the 4G dongle. How long is the data plan for those?
Yeah, so that's going to be 12 and a half years, and that's based off updating every 15 minutes. There are options that you can change the download speeds, for that. However, if you do change it, the time is not guaranteed longer for 12 and a half years, right? So if you're not careful, if you change it to, too quick, then you can run out technically. Like, so if you change it from 15 minutes to 1 minute, you're basically going from like your 12 and a half years down to like 2.
Thank you. And then best number to call in case of commissioning or any other issues, Bill?
Yeah, so you can definitely use our, toll-free number. We do have a, after sale team as well. So if you contact me on that's my cell phone number right there. So if you contact me or text me, I will absolutely respond, within a very short period of time, typically within 1 hour. If I don't, definitely call me. Typically, if you say you're in the field, then if I'm, doing a call like this, for instance, or if I'm disposed, we do have after-sale engineers that I can forward you to make sure that you get you taken care of if you're in the field.
Perfect. And the toll-free number is 888-819-5189. Yeah, okay, so I think that just about wraps it up. Again, Bill, thank you so much for taking the time today.